Good day, viewers. This is 300 Plus Academy, where all we do is exams tutoring, ensuring that you ace your next exam. Still on the subject chemistry, still looking at redox reactions, but this time around, we'll be looking at how to balance redox equations by what we call half reaction method or ion-electron method, talking about this method of balancing redox equations. This is very, very common with O-level exams like WAEC, NECO, and the likes. In balancing redox reactions by ion-electron method, there are about 9 steps to take depending on if the reaction is taking place in an acidic medium or in an alkaline or a basic medium. If it is taking place in an acidic medium, as you can see on your screen, we have about 7 steps to follow to get a balanced equation. And if taking place in an alkaline medium, we have about 9 steps to follow in getting a balanced equation. As you can see on your screen, the first step talks about separating the reaction into oxidation and the reduction half reaction. The second step talks about balancing atoms other than hydrogen and oxygen. The third step talks about adding 1 mole of water for every oxygen atom that is lacking. The fourth step talks about adding hydrogen ion for every hydrogen atoms lacking. The fifth step is about balancing the charge and adding electrons to the more positive side. The sixth step talks about using appropriate integers to make the electron loss equal to the electron gain. And then the seventh step is about cancelling out whatever is the same on both sides to get the desired equation. And if it's in a basic medium, you move to step 8. That's if the reaction takes place in an alkaline medium, the add to both sides of the equation same number of hydroxyl ion as there are hydrogen ion. And step 9 talks about combining hydrogen ion and hydroxyl ion to form water and collect it to one side of the equation. Now, all of this looks easy to talk about theoretically, but I think it's going to make more sense if we have what question looks like when we talk about balancing equation using ion-electron method and trying to follow all of these 9 steps. So when we have questions like this, it's usually around 8 to about 10 marks. So looking at the question, it says balance this equation. Balance this equation if the reaction takes place in an acidic medium. This is the equation we are trying to balance: tetraoxomanganate ion and the C2O4 2 minus to give us this. So what are the steps we are going to follow? Now, the first step we follow in for ion electron method, step 1 is to separate this equation into oxidation and reduction half reaction. There are so many ways to look at this. I could look at this. This is MnO4. This is Mn. This is about loss of oxygen. You recall that removal of oxygen from a substance is reduction. If you look at it in terms of oxygen, that's reduction. And as well, if you look at this in terms of oxygen as a C2O4 and a CO2, that is also looking like removal of oxygen. So you see that when you talk about balancing equations using ion-electron method, it's not going to be about oxygen. Rather, it's more than that. You have Mn2 plus here. Now I could go here for MnO4 minus to give me Mn2 plus. What I have to do here is I have to try and look for the oxidation number of manganese here. Talking about manganese, let my manganese be X. Oxygen is minus 2 times 4, that is minus 8, all equals to minus 1, because this is a radical and the sum total of all the oxidation state equals to the charge that we have here. So this is x minus 8 equals to minus 1. So x equals to minus 1 plus 8. X equals to plus 7. So what this means is that my manganese had moved from plus 7 to plus 2. So when I look at this looks at a decrease in oxidation number, and we all know that reduction is what? Reduction is a decrease in oxidation number. Reduction is a decrease in oxidation number. So when I look at this MnO4 minus to Mn2 plus, that is reduction. And when you look at this is C, carbon is the oxygen is here. This is minus 2 to 0. This is not charged to 0. Minus 2 to 0, that's an increase in oxidation number. That is oxidation. Oxidation is increase in oxidation number. So the first step in balancing this equation is to separate into oxidation and reduction. I've always said talk about oxidation first, because oxidation is the loss of electron, and it is the electron that is being lost that can now be gained, then reduction next. So in this case, my oxidation reaction is C2O4 minus to give us CO2, minus 2 to 0. That's an increase in oxidation number. So C2O4 minus to give me CO2. That is my oxidation half reaction. And MnO4 minus, I haven't calculated the oxidation state of manganese, that's plus 7, and manganese is now 2 plus. That's a reduction in oxidation number, decrease in oxidation number. So that is reduction to give me Mn2 plus. That is reduction half reaction. That is step 1. Step 2 talks about balancing atoms other than hydrogen and oxygen. Forget about the oxygen here. Try to balance the other atom. When you look at this, this is C2, this is 1C. The carbon is not balanced. I'll try to balance that. C2O4 minus to give me CO2. But since I have 2 carbon here, this will be 2CO2. Mn. So the reduction half reaction seems balanced already. Step 3, balancing oxygen atom. To the side that lacks oxygen, we're going to add 1 mole of water for every oxygen that is lacking. Step 3 talks about balancing oxygen. To the side that lacks oxygen, we're going to add 1 mole of water for every oxygen atom lacking. So when we look at this equation from step 2 here, I have 4 oxygen here, I have 2 times 2, 4 oxygen here. So the oxygen is balanced there. So C2O4 minus to give me 2CO2. But this is it. MnO4 minus, I have 4 oxygen here, no oxygen on the product side here. So since 4 oxygen is lacking, I'm going to be adding 4 moles of water here. So this is MnO4 minus to give me Mn2 plus 4 moles of water. Now that ends step 3. We've been able to balance oxygen by adding water to the side that lacks oxygen. Step 4 talks about balancing hydrogen. For every hydrogen atom that is lacking, we're going to add 1 mole of hydrogen to the side that lacks hydrogen. We are going to try to balance hydrogen. For every side that lacks hydrogen, we are going to add hydrogen ion. In this situation, C2O4 minus, the oxidation reaction does not even have hydrogen, so that is already balanced. C2O4 minus to give us 2CO2. But when you look at the reduction reaction there is about 8 hydrogen here. 4 times 2, 8. No hydrogen on the reactant side. So to the reactant side that lacks hydrogen, we're going to add 8 moles of hydrogen ion. So this is going to mean MnO4 minus plus 8H plus to give us Mn2 plus 4H2O. That way we've been able to balance hydrogen. Look at it again. The first step is to separate this into oxidation and reduction half reaction. The next step is to balance atoms other than hydrogen and oxygen. The third step is to try to balance oxygen. For every oxygen atom that is lacking, you add water to the side that lacks that oxygen. Then step 4 talks about balancing hydrogen atom. For every hydrogen atom that is lacking, you add hydrogen ion to the side that lacks the hydrogen. Step 5 talks about balancing the charge. And how do we balance the charge here? We add electrons to the more positive side. Now, in balancing the charge, look at it. C2O4 2 minus. For the reactant here, this is -2 and this is 0. So when you look at that, -2 to 0. Now the difference between -2 and 0 is 2 electron. But which side is the more positive side? That is the product side. So we'll be adding 2 electron to the more positive side. Look at it again. Step 5, balance the charge by adding electrons to the more positive side in each half equation. Looking at it again, -2, that's the charge here. This one is not charged, that is 0. -2 to 0, the difference is 2 electron. Which side is the more positive side? The product side, which has a charge of 0. So we'll be adding 2 electrons to that, so that this will mean C2O4 2 minus to give us 2CO2 plus 2 electron. So we've been able to add 2 electrons to the more positive side. Looking at the second equation, MnO4 minus, we have a -1 here, and this is H plus, that's +1, but we have 8. 8 times +1, that is +8, to give us 2 plus 2. H2O here means 0 plus 0. So all the reactant here means +7 to +2. What is the difference between +7 and +2? That's 5 electron. Which side is the more positive side? The 7 plus, that's the reactant side. So I'm going to be adding 5 electrons to the more positive side here. That's the reactant side. So that what this will mean is MnO4 minus plus 8H plus 5 electron to give us Mn2 plus 4H2O. Look at it very well. We are trying to balance the charge by adding electrons to the more positive side. So you just sum up the charge on the reactant side, the charge on the product side, look for the difference, and when you get the difference, add that difference to the more positive side. In this case, this is MnO4 minus, that's -1. So we have -1 here. This is hydrogen ion, H plus, that's +1, but because we have 8 here, 8 times +1, that is +8. So -1 plus 8 will give us +7 for the reactant side. Now this is +2, this is 0, so that is going to give us +2. The difference between 7 and 2 is 5. We'll be adding 5 electrons to the more positive side, and that is why we're adding this 5 electron here. That ends step 5. For step 6, we're going to make the electrons gained equal to the electron loss. Electron loss equals to the electron gain. This looks like 2 electron has been lost here as we have the electron on the product side. This looks like 5 electron has been gained there as we have the electron to the reactant side. So what that means is you're going to use these 2 here to multiply the second equation, and you'll be using this 5 to multiply the first equation. So what that means is that 5 times C2O4 2 minus, that will give you step 6, that will give you 5 C2O4 2 minus 5 times 2CO2, that will be 10CO2. 5 times 2, that will give us 10 electron. Then you've used 5 to multiply the first equation. Then you use this 2 to multiply the second equation. 2 times MnO4 minus, that will give you 2 MnO4 minus. 2 times 8H plus, that will give you 16H plus. 2 times 5 electron, that will give you 10 electron. 2 times Mn2 plus, that will give you 2 Mn2 plus. 2 times 4H2, that will give you 8H2O. So that is what it means to make the electron lost equal to the electron gain. And step 7, since this takes place in an acidic, this is taking place in an acidic medium, we are going to stop at step 7. The step 7, which is the last step, if it takes place in an acidic medium, is for us to, collect the equation together and cancel anything that is the same on both sides to get the desired equation. How do we do that? What it means is that we are going to take all of the reactants together. We are going to take all of the reactants together. So that's going to mean this and this. We would have to take all of the reactants together. We have to take that together before. So what we have is 5C2O4 2 minus plus 2MnO4 minus plus 16H plus 10 electrons. So we've been able to take all this together to give us the product. What is the product? The product here is 10CO2 plus 10 electron to give us 2Mn2 plus 8H2O. So whatever it is that is the same on both sides is what we are going to strike out. Now looking at this very well, 10 electron here and the 10 electron here the same. Aside that, nothing is the same on both sides again. So our balanced equation here is 5C2O4 2 minus plus 2Mn O4 minus plus 16H plus to give us 10CO2 plus 2Mn2 plus 8H2O. This here is our balanced equation using ion-electron method. So you can see, usually when you have questions like this in your exam, it's usually about 8 to 10 marks. So moving on, let's take another example. As you can see on your screen, in this case, the equation has not even been constructed. You have to be the one to look for the equation here. In this case, the question has two parts, A and B. It says, state what you would observe when iron 2 salt is one with tetraoxomanganate 7 solution. State what you would observe when iron 2 salt. When we say iron 2 salt here, iron 2 salt means Fe 2 plus. Like under normal exam condition, you can have your question like this where the equation is not even written for you, so that it's not just that you want to follow step 1 to 7 or step 1 to 9, but it may be that you have to construct everything and interpret everything from the basis. So you look at it. State what you would observe when iron 2 salt. To say iron 2 salt is to say iron 2 ion is warmed with tetraoxomanganate 7 solution. To say tetraoxomanganate 7 solution is to talk about MnO4 minus. And anytime iron 2 ion goes into a reaction, it's very likely going to end up with iron 3 ion. And when MnO4 minus, just like in the previous question, once we have this, that MnO4 is from actually KMnO4, and the color of this KMnO4 is actually pink, or you call it purple. Once you have KMnO4, like they said in that question, it says tetraoxomanganate 7 solution. What you're going to have is MnO4 minus, because the potassium ion you're going to have on the reactant side is exactly what you'd have on the product side, and this would have strike this out. So you're talking MnO4 minus, and that's going to end up with manganese 2 ion. That is the sequence. So looking at question 8, telling us to look for the state what you would observe when iron 2 salt is 1 with tetraoxomanganate 7 solution. The best approach to this is to first of all look at the color. The color of this is actually pink, and this here is going to be colorless. This is going to be pink, and this becomes colorless. Iron 2 ion is actually green. Iron 2 ion is actually green, and iron 3 ion is brown. So you have a case of the iron 2 ion changing to brown iron 3 ion. So that is what this speculates. So what you say here is that purple tetraoxomanganate, that's the pink tetraoxomanganate, is decolorized, while green iron 2 ion 2 plus to 3 plus, that is increase in oxidation number. Increase in oxidation number talks about oxidation. Green iron 2 ion is oxidized to brown iron 3 ion. So this here just answers question A, telling us what is observed when iron 2 salt is 1 with tetraoxomanganate 7 solution. So the next question there states, balance the redox reaction between tetraoxomanganate 7 and iron 2 ions in acid solution. So you can see, if you don't get the right equation from the first step, then every other thing you're going to do is going to end up being wrong. So how are we going to go about this? So look at B. We want to actually balance the equation. So the first thing is to separate into 2 half equation. Iron 2 ion, we're going to start with oxidation first. Iron 2 ion to iron 3 ion, that is oxidation, because why? Oxidation is increase in oxidation number from +2 to +3. So what you have is Fe 2 plus to give you Fe 3 plus. That is our oxidation half reaction. And then MnO4 minus. In MnO4 minus, like I did in the last question, MnO4 minus to give you Mn 2 plus. When you calculate the oxidation state or the oxidation number of manganese, let this be X. This is going to be plus minus 2 times 4 equals to minus 1. This will be X minus 8 equals to minus 1. So X equals to minus 1 plus 8. So X equals to plus 7. So from plus 7 to plus 2, that's a decrease in oxidation number, and that is why MnO4 to give us Mn 2 plus is actually a reduction half reaction. So this is step 1 in balancing our redox reaction. Step 2 talks about balancing atoms other than hydrogen and oxygen. And when you look at this, we have one ion here, one ion here. This is balanced. MnO4, Mn2 plus. We are not concerned with oxygen now. We are only concerned about other atoms aside hydrogen and oxygen. One Mn, one Mn. So step 2 looks okay already. Let's move to step 3. Step 3 talks about balancing oxygen atom. For every oxygen that is lacking, you're going to add 1 mole of water. Talking about step 3, it is still Fe2 plus to give me Fe3 plus, because I don't have any oxygen here. But for this, I have 4 oxygen here, I have no oxygen here. So for every oxygen atom that is lacking on the product side for the reduction half reaction, I'm going to add 1 mole of water. So what I have here is MnO4 minus to give me Mn2 plus manganese 2 ion plus 4 moles of water. So that ends step 3. Moving to step 4. For step 4, what we are going to try to do here is to balance the hydrogen atom. For every hydrogen that is lacking, we're going to add hydrogen ion to the side that lacks hydrogen. For the oxidation half reaction, everything looks pretty set. Fe2 plus to give Fe3 plus. Then here, that is MnO4 minus. Now when you look at this, there is about 4 times 2, 8 hydrogen here. Now the reactant side lacks hydrogen, so that is going to be plus 8H plus to give us Mn2 plus 4H2O. So that ends step 4. Now moving on to step 5. Step 5 talks about balancing the charge. We are going to try to balance the charge for step 5. This is 2 plus, this is 3 plus. The difference between this and this is just 1 electron. So we'll be adding that electron to the more positive side. 3 plus is the more positive side. So this is Fe2 plus to give me Fe3 plus plus just 1 electron here. But when I look at this, MnO4 minus, that's minus 1. H plus is plus 1 times 8 plus 8. Minus 1 plus 8, that's going to give us plus 7. So on this reactant side, we have plus 7. Now the water here, H2O, water is 0, is not charged. The sum total of the oxidation number for a compound is 0. But for my manganese here, it is plus 2. So I have plus 2. The difference between plus 7 and plus 2 is 5 electrons. So I'll be adding the 5 electron to the more positive side, and that is the reactant side. So that what I have here is MnO4 minus plus 8H plus 5 electron to give me Mn2 plus 4H2O. This here, is the end of step 5. So step 6, what I'll be doing for step 6 is to, make the electron lost equal to the electron gain. And when I look at this, is just 1 electron. I'll use 1 to multiply equation 2, and then I'll use 5 to multiply equation 1. Using 5 to multiply equation, using this 5 from the 5 electron to multiply equation 1, what I'm going to have is 5 Fe2 plus to give me 5 Fe3 plus 5 electron, using 5 to multiply this. Then using 1 to multiply this, I'm just going to have about the same thing. 1 times MnO4 minus will still give me MnO4 minus plus 8H plus 5 electron to give me Mn 2 plus 4H 2O. So that's the end of step 6. For step 7, I'm going to try to collect all of the reactants together and collect all of the product together and cancel out anything that is the same on both sides. In the case of this, what I have is my reactant is talking about those things I have before the arrow. So this is going to give me 5Fe2 plus 5Fe2 plus 5Fe2 plus MnO4 minus plus 8H plus 8H plus 5 electron to give us 5Fe3 plus 5Fe3 plus 5 electron to give plus Mn2 plus 4H2O. So what is the same on the product and the reactant side? If you look at it very well, it is the 5 electron, this out. So that what we are left with as our answer is 5Fe2 plus MnO4 minus plus 8H plus to give us, 5Fe3 plus Mn2 plus 4H2O. This here is a balanced equation for the reaction between iron 2 ion and tetraoxomanganate ion. And that's what you have there. We stop at step 7 if the process takes place in an acidic medium, as you can see. Taking the last question, talking about question 3, to look at what we should do if we have the redox reaction happening in a basic medium. So how do we balance things using ion-electron method? So we follow step 1 to 7 first, just like we've done for the previous questions when we have them in acidic medium. Then we use step 8 and 9 to complete things because this is happening in a basic or alkaline medium. So what is step 1? Step 1 talks about, separating the equation into oxidation and reduction of reaction. So looking at this, manganese in MnO4, for MnO4 minus, to get MnO2, this is tetraoxomanganate ion. This Mn here is plus 7, Mn here is plus 4. This is manganese 4 hydroxide. So this is a reduction in the oxidation number. And even if you look at it in terms of oxygen, in this case, O4 to O2, that's loss of oxygen, that is reduction. But when you look at SO3 and then SO4, that shows, oxygen has been added to SO3. So looking at this, our oxidation here is going to be step 1. Our oxidation is going to be SO3 2 minus to give us SO4 2 minus, while our reduction reaction is going to be MnO4 minus to give us MnO2. So that ends that. Now to step 2. Step 2 talks about balancing atoms other than hydrogen and oxygen. I have one sulfur here, that seems balanced. I have one manganese here, that seems balanced. So step 2 of this ion-electron method is well taken care of. So we move straight to step 3. Step 3 talks about balancing oxygen. For every oxygen that is lacking, we add 1 mole of water to the side that lacks oxygen. We have O3 here, we have O4 here. So what this means is SO3 2 minus, the difference between O3 O4, that's 1 oxygen. We add 1 mole of water to the reactant side here to give SO4 2 minus. MnO for MnO2, this side lacks 2 oxygen. We add 2 moles of water here, so MnO4 minus to give you MnO2 plus 2H2O. And step 4 is about hydrogen. We want to balance hydrogen. To the side that lacks hydrogen, we're going to add 2 moles of hydrogen ion. SO3 2 minus plus H2O to give me SO4 2 minus. I have 2 hydrogen here. Then I'm definitely going to put 2 hydrogen ion on the product side. So SO3 2 minus plus H2O, that's going to be SO4 2 minus plus 2H plus, because this side lacks hydrogen. And in the case of this, the product side has 4 hydrogen, so I'm going to be adding 4 hydrogen ion to the reactant side. So that is MnO4 minus plus 4H plus 4H plus to give me MnO2 plus 2H2O. That ends step 4. Talking about step 5. Step 5 here is going to talk about, balancing the charge. Now this is 2 minus here. This is 0. So for SO3 2 minus and water here, this is minus 2. This is 0. So I have minus 2 to what? This is minus 2. Hydrogen is plus 1. 2 times plus 1, that's plus 2. Plus 2, and I have minus 2 here and plus 2. So this will be minus 2 to 0. So the difference between what I have here and what I have here is 2 electrons. So I'll be adding the 2 electrons to the more positive side, which is the product side. That way, this is going to mean step 5, SO3 2 minus plus H2O to give us SO4 2 minus plus 2H plus. We are adding the electron to the more positive side, and this is plus 2 electron. That's it. Moving here, this is minus 1. This is minus 1. 4H plus plus 1 times 4, that is plus 4. Minus 1 plus 4 will give us plus 3. So what do we have here? MnO2, this is a compound, 0. 2H2 is a compound, that is also 0. So minus 3 to 0. So the difference is 3 electron. We'll be adding the electron to the more positive side, and that is the reactant here. So that this means MnO4 minus plus 4H plus, as we can see, 4H plus. We'll be adding 3 electron plus 3 electron to give us MnO2 plus 2H2O. MnO2 plus 2H2O. Now step 6 talks about making the electron loss equal to the electron gain. So I'll be using the 2 electron in the first equation to multiply the second equation, and I'll be using the 3 here to multiply the first equation, so that what we have here is going to be 3 times is that to be 3SO3 2 minus plus 3H2O to give us 3SO4 2 minus 3 times 2H plus will give us 6H plus 3 times 2 electron will give us 6 electron. Then I'm going to use 2 to multiply this. That will be 2 MnO4 minus plus 2 times 4H plus 8H plus 2 times 3 electron 6 electron. 2 times MnO2 will give us 2 MnO2 plus 2 times 2H2, that will give us 4H2O. So that said, now step 7 talks about making cancelling out what is the same on both sides. So when you look at this, when you try to write out all of the reactants for step 7, this is all of your reactants. This is all of your reactants, and this here is all of your products. So when you look at it, what is the same on both sides? Step 7, when you look at this, I have water here, I have water here, I have 8H plus here, I have 6H plus here, I have 6 electron, I have 6 electron. So let me just, for the sake of completion, let me write this out. So this step 7, that's going to be 3SO3 2 minus plus 3H2 plus 2MnO4 minus plus 8H plus 6 electron minus. Now the product here is going to be 3SO4 2 minus plus 6H plus 6 electron plus 2MnO2 plus 4H2O. So what is the same on both sides if we look at this? Okay, starting with water, 3 moles of water we take out 3 here. So I'm going to be left with 1 here, 1 mole of water. 8H plus, okay. 6 will cancel out here. I'm going to be left with 2 here. And 6 electron, we take out 6 electron. So when I look at all of this, that's just about it. That's just about it. So for step 7, what I'm really going to have is 3SO3 2 minus plus 2MnO4 minus. We are left with 2H plus here. That is our reactant. And then our product is going to be 3SO4 2 minus plus 2MnO2, that's manganese 4 oxide, plus we're left with 1 mole of water here. So this stops for step 7. So but because this takes place in a basic or alkaline medium, we then talk of step 8 and step 9. Step 8, as you can see on your screen, is that you're going to add to both sides of the equation the same number of hydroxyl ion as there are hydrogen ion. Now what that means is that for every hydrogen ion I have, I'm going to add hydroxyl ion to both sides. So looking at this, this is going to be 3S, this is step 8, 3SO3 2 minus plus 2MnO4 minus plus 2H plus because of the hydrogen ion, I'm going to be adding 2 hydroxyl ion now, but I'm going to be adding that to both sides. So to the other side, that's 3SO4 2 minus plus 2MnO2 plus H2O plus OH minus 2OH minus, because it is 2 hydrogen ion that I have. So that's, I'm going to have 2OH minus. For step 9, what I'm going to do is that I'm going to collect the hydrogen ion and the hydroxyl ion together for step 9. For step 9, you look at it. 3, that means 3SO3 2 minus plus 2MnO4 minus 2H plus and 2OH minus. That will give us 2H2O, and this will give us 3SO4 2 minus plus 2MnO2 plus H2O plus 2OH minus. So what's going to happen here is that we are going to collect the water to one side. I have two H2O on the reactant side. I have H2O on the product side. So the water here is going to take out one out of the water here, so that my balance equation is 3SO3 2 minus plus 2MnO4 minus. I'm left with just 1 mole of water here to give me 3SO4 2 minus plus 2MnO2, no more water here, plus 2OH minus. This here is a balanced equation because the reaction takes place in an alkaline medium, and that just ends it. This is how you balance redox equations by half reaction, or what we call ion-electron method. Do not forget, this is the channel you need to be to ace your next exam. Hit the subscribe button, share with your peers, and I tell you, they'll be glad you did that for them. From myself and the team, it's bye for now.